We discussed question 1 and question 2 of A-level mathematics paper 5 in May or June of year 2020. Question 1. The score when two fair six-sided dice are thrown is the sum of the two numbers on the upper faces. When we throw two dice, the outcomes are either 1, 1, 1, 2, 1, 3, until 6, 6 here. So what we need to look at is the score. The score is the sum of the outcome. So 1, 1 has a score of 2, 1, 2 has a score of 3, 1, 3 has a score of 4, and 6, 6 has a score of 12. In total, there are 36 outcomes. We are only concerned with the score of 4. So when we look at the score of 4, we are looking at the case where we have the outcomes of 1, 3, 3, 1, and 2, 2. There are only 3 outcomes with a score of 4. So the probability of getting a score of 4, there are 3 outcomes with a score of 4 out of 36 outcomes in total. So that is 1 out of 12. The second part of the question. The two dice are thrown repeatedly until a score of 4 is obtained. The number of throws taken is denoted by the random variable x. So for this case, for the second part here, x denotes the probability, x denotes the number of throws until a score of 4 is obtained. So we have the number of throws until a score of 4 is obtained. The number of throws until the first success occurs follows a geometric distribution. In this case, the number of throws until a score of 4 is obtained. This random variable x follows a geometric distribution where the probability of obtaining a score of 4 is given by 1 out of 12 from part A. Part B, we need to find the mean of x. The mean of a geometric distribution is the reciprocal of the parameter p, the probability of success, which is 1 out of 12. So you have 1 divided by 1 out of 12, and that is a value of 12. Part C, find the probability that the score of 4 is obtained on the 6th throw. So the probability that the score of 4 is obtained on the 6th throw. On the 6th throw, we have a score of 4 that comes with probability 1 over 12. But we have 5 throws that do not result in a score of 4. So the probability of failure is 11 out of 12. That is raised to the 5. There are 5 failures followed by 1 success. And that has a value of 0.0539. Part D, to find the probability that x is less than 8. Since x follows a geometric distribution, now if x follows a geometric distribution with probability of success p, then probability x less than or equals to k, that is given by 1 minus p to the k. That will give you the cumulative probability up to and including k for a geometric random variable. X less than 8 indicates that x must be less than or equals to 7, since geometric is a discrete distribution. So for this case, we use the formula for the cumulative probability that will give us 1 minus, this is 1 minus 1/12 to the k. K would be 7. So we have 1 minus 11 out of 12 to the 7. And that results in 0.4561. Question 2 is a permutation question. Part A. Find the number of different arrangements. Arrangements indicates permutation that can be made from the 9 letters of the word jewelry, in which the 3 E's are together and the 2 L's are together. Let's rearrange this word. You have a J, and then if the E's are together, there are 3 of them. The 2 L's are together, and you have WRY. In total, you have 9 letters. But if you want the 3 E's to be together, you hold this as one letter, one object. The 2 L's are together. So these 2 L's are held as the same object. So we have 1, 2, 3, 4, 5, and 6 objects here that we need to permute. Then the number of arrangement is 6 factorial. Since the E's are together and you cannot distinguish one E from another. 6 factorial is 720. Part B. Find the number of different arrangements that can be made from the 9 letters of the word jewelry again. The 2 L's are not next to each other. So the 2 L's cannot be together. Then we are looking at the number of arrangement where the L's are not together. We use the complement. So the number of arrangement when the L's are not together, this is given by the total number of arrangement minus the number of arrangement where the L's are together. Then in that case, we will have the number of arrangement where the L's are not together. Total number of arrangements. There are 9 letters in total, so we have 9 factorial. But we have repeated objects, 3 E's, so we divide by 3 factorial. 2 L's, we divide by 2 factorial. Now the number of arrangement where the L's are together. So for this case, we have all these, the L's are held. These 2 L's are now considered one object. So in total, you have 1, 2, 3, 4, 5, 6, 7, 8 objects here. Then the number of arrangement where the L's are together is given by 8 factorial. The 3 E's are repeated objects, so we must divide by 3 factorial. So the first part here, you have 30,240, and the second one, you have 6,720. So the number of arrangements in which the 2 L's are not together is 23,520.